Hello friends, let's discuss the JEE Mains paper which you did on 6th August. So I'll directly start with question number 1. So this question says that in which of the following elements the above principle is not been followed in the electronic configuration. Okay, so important thing is above principle. Okay, so above principle says that energy order is according to n plus L value. So you remember that n plus L, this is also called n plus L rule. So here, if you take electronic configuration of copper and chromium, so for copper it is 3d10 and 4s1. Now if you check the energy of 3d and 4s, so energy of 4s is less than 3d. So 3d should be filled after complete filling of 4s. So here you have only one electron in s and 3d is being filled. So it means copper is not following Abba principle. Similarly, chromium, these two are the exceptions in electronic configuration. This is 3d5 and 4s1. So again 3d is getting filled, even 4s is not completely filled. So your answer will be copper and chromium, D. Let's come to the next problem, which is again very simple one. See, which combination of quantum number is not permissible? Okay, so its simple answer will be C, because here you have n is equal to 3 and L is equal to 3. Okay, so you know that value of L is 0 to n minus 1. So if n is 3, then maximum value of L could be 2. The permissible value of L is 0, 1 and 2. So this combination is not possible. Fine. So let's come to question number 3. In question number 3, uh, which of the following set of quantum numbers is not possible? So let's take first option. So 3, 0, 0 plus 1. So this seems possible because you know the limit L 0 to n minus 1 m minus L2 plus L. Now 2, option 2. So 2, 2, 1. So if n is 2, then L could, maximum value of L could be 1. Fine. So this is not possible. 4, 3 minus 2. This seems possible. If n is 4, then L could be 0 to 3. So it's fine. M could be minus 3 to plus 3. It is also correct. S is minus 5. So this is permissible. 4, 1, 0 minus 1. So this is incorrect. This cannot be correct because if L is 0, then M should be 0. Fine. 5, 3, 2, 3. Again, if L is 2, then M should be minus 2 to plus 2. So this is also not possible. So 2, 4 and 5 are not possible. So answer will be 3. C. Next is, which of the following expression represents the electron probability function? So electron probability is psi square is probability density into volume. That will be probability function, right? So dV is equal to 4 pi r square into dr. So d should be equal to 4 pi r square dr into psi square. So let's check that. 4 pi r dr psi square, 4 pi r square dr psi. So this is not, could not be the answer. 4 pi r square dr psi square. Yeah, so C will be the correct answer. So these all questions are very simple. Okay, now question number 5. Which of the following is the correct for number of electrons, number of orbitals and type of orbitals respectively in n orbit? Okay, so this is n orbit, means K, L, M, N. So n is the major energy shell. So principal quantum number is 4. So total number of electron will be 2n square, which will be 32. So total number of electrons will be 32. So directly you can say answer is C. We can solve for number of orbitals. So number of orbitals will be n square, because in one orbital you can have maximum 2 electrons. So you have 2n square electrons, so number of orbitals will be n square, which is equal to 16. And since principal quantum number is n, 4, so you will have 4 types of orbital: s, p, d and f. Fine, so answer will be C in this case. Now let's come to question number 6. Number of nodal planes, right? So nodal planes is nothing but angular node. It is angular node, okay? And we know the number of angular node is equal to L. So for D, 5D, so D, for D, L is equal to 2. So number of angular nodes or nodal plane will be 2. Now let's discuss question number 7. Magnitude of kinetic energy in an orbit is equal to. Okay, fine. So we solve this in the lecture also, that uh, potential energy is equal to minus k ze square by r, and kinetic energy is equal to kze square by 2r. So we have to check only the magnitude of kinetic energy. So magnitude of kinetic energy will be equal to half of the potential energy. Okay, so half of the, so you neglect the sign. So half of the potential energy is kinetic energy. So answer will be A in this case. Now let's come to question number 8. It says that the uncertainty in position and momentum are equal, then uncertainty in velocity. So you have to take minimum uncertainty in this case. So we know that delta x into delta p is equal to h by 4 pi, and it says that delta x is equal to delta p. So you can say that delta p square is equal to h by 4 pi. So delta p, from here you can say that delta p is 1 by 2 h by pi, and delta p is nothing but m delta v. So delta v will be equal to 1 by 2m h by pi. So this will be the answer. So here delta v is equal to 1 by 2m under root h by pi. Okay. Now question number 9. So question number 9 says that the number of waves made by a Bohr electron in an orbit of maximum magnetic quantum number 3. So magnetic quantum number is m. M should be equal to 3. It means maximum value. Then L should be equal to 3, because m is value of m is minus L to plus L. And if L is 3, then n, principal quantum number, the major energy shell, it should be equal to 4, right? If n is 4, then L could be 3. So if n is 4, then the orbit number, or you can say the major energy shell, will be 4 only. So and in that, in fourth major energy shell, or you can say in the fourth orbit, the number of waves will be 4 only. So basically in this question, this question is a bit tricky, because it is a combination of principal quantum number and Bohr theory, and you can say that you need to apply the concept of matter wave also. So again I am explaining this. If magnetic quantum number is 3 maximum, then L should be 3, and for L is equal to 3, n should be equal to 4. Minimum value of n should be 4. So in fourth major energy shell, or in the fourth orbit, the number of waves will be 4. Now let's come to question number 10. So an electron jumps from higher energy level to ground state, and the energy emitted is lambda. So you need to tell that in which orbit or in which shell electron was present. So in this case, you apply this concept. 1 by lambda is equal to r 1 minus 1 by n square. So this is the final energy shell is 1 and initial is n, and you need to find out n. R is Rydberg constant. In the options also R is Rydberg constant. So if I solve this here, so you can say that 1 minus 1 by n square is equal to 1 by lambda into r. So 1 minus 1 by lambda r is equal to 1 by n square. So lambda r minus 1 by lambda r is equal to 1 by n square. So n is should be equal to lambda r upon lambda r minus 1. So correct answer will be B.